All right, guys, welcome back. We're getting close to the end of activity 30. The last section is going to be talking about rhombuses and trapezoids, but before we get to that, let's go over the answers from 30.2. We were looking at area of triangles, okay? So I assigned 10 through 16. I'm just going to kind of run through these real quick. Number 10 was kind of testing that new formula I gave you, that 1/2 BC sine A. And so you're just plugging in the values they give you. So 1/2 times 5 times 7 times sine of 49, that is about 13.2. Number 11, same idea, only you're going to do 1/2 times 10 times 24 times sine of 38. You get 73.9. Number 12, they give you a parallelogram. They say, hey, use the idea that you've got some triangles here and find the area. Well, you have two triangles, so you've got 2 times the formula for a triangle, 1/2 base times height. And so the 2 and the 1/2 kind of cancel each other out. You get base times height is the formula for the area of a parallelogram. And in this case, the area is going to be 30 because it's 6 times 5. Number 13. Number 13 is an equilateral triangle with side lengths of 8.5. Keep in mind when you find that height, it's going to be half the side times the square root of 3, so 4.25 times the square root of 3. You multiply it all out, you get 1/2 times 8.5 times 4.25 times the square root of 3, and you get 62.6. Number 14. Number 14 is pretty straightforward. It's just 1/2 of 6 times 3. That one you have to put on the graph, so as long as you graph it correctly, you should be good there. Number 15 is just like numbers 10 and 11. You take the numbers they give you, it doesn't matter, as long as you put the sides here and the angle over here. So we get 1/2 times 15 times 12 times the sine of 30, and so you get an answer of 45. Number 16. Number 16 is 1/2 times 4 times the square root of 45. That 45 comes from 7 squared minus 2 squared. Okay, that's the Pythagorean theorem that you need to do in order to get the side length of that isosceles triangle. Sorry, the height of that isosceles triangle. So this is 1/2 times the base, which is the 4, because the 2 7s match, so the 4 is the base. And then square root of 45. When you multiply that all out, you get 13.4. All right, so that is numbers 10 through 16. Hopefully that makes sense. Let's talk about some rhombuses and some trapezoids, yeah? We're looking at page 441, and I'm just going to kind of run you through the formulas real quick, because I think we're at a point where you just want to kind of do some math, all right? So area of a rhombus, 1/2 times the diagonal times the diagonal. 1/2 D1, D2. All right, those D stand for diagonal, not distance. Diagonal. I did a drawing here, but it's kind of hard to label the diagonal, so keep in mind diagonal is the full length all the way across the shape. In my example here, I went ahead and told you AC, so AC is this diagonal going up and down is 20, and DB or BD is 15. So the formula says that I would do 1/2 times diagonal, so 1/2 times 20 times 15. And so my area for my example is 150, and all rhombuses are going to work that way. The thing to watch for, know that because it's a rhombus, this angle in here is a 90-degree angle, and so you're going to see things like maybe they give you that this length out here is 5, and they tell you this length is 3, and you could actually solve the rest of the shape from that point, okay? If this is 3, this has to be 3. If this is 5 and this is 3, this length has to be 4, and so this length has to be 4. And so then we have both of our diagonals, this one total length of 6, this one total length of 8. We put a 1/2 out front, we multiply everything together, 6 times 8 is 48, half of which is 24. So this little bit of information could be used to find the area, so be careful with that. You're going to see a lot of right triangles and Pythagorean theorem keep coming up with rhombuses. Trapezoids. The biggest mistake I see made with trapezoids is people get confused about the bases. Which one's base 1, which one's base 2? It doesn't matter. What matters is that the bases are the parallel sides, okay? And so our formula is 1/2 B1 plus B2 times H. Notice the B's get added together before you multiply, okay? And they are the parallel sides. As such, notice my example. I have a trapezoid that's kind of stood up on its end. The 5 is not the base, okay? The base are the parallel sides. So you're going to want to do 1/2 times 10 plus 6, which is 16, times 5. 10 plus 6 is 16, half which is 8. 8 times 5 is 40. So the area of this trapezoid is 40. And that's probably the most common mistake I see made there is people get confused about the bases. Okay. Also, don't forget that your height has to be perpendicular to the bases. So let's say we had this trapezoid here, and they did maybe this is, let's go with a pretty simple one. Let's go with it being an isosceles trapezoid, meaning those two sides match. Let's put a 10 up here, and let's put 16 here, and let's put this length is 5 and this length is 5. Okay, what's the area of that trapezoid? you can't find it right away. Why not? Because you're not given the height. So what you have to do is you have to solve for this measurement, okay? Because it's isosceles, this length and this length are going to match each other. If it's 10 on top, 16 on bottom, that's a difference of 6, right? That means there's 3 here, there's 3 here, there's 10 in the middle, and they would all add together to get 16. Well, if there's 3 here and a 5 here, remember Pythagorean triples, that means our height has to be 4. So if I'm finding the area of this trapezoid, it's going to be 1/2. We're going to add the bases, 10 plus 16, we're going to get 26. And then our height is 4. So my area, 1/2 of 26 times 4 is going to be 52. Okay? And that's for that trapezoid. So keep in mind, you are going to have to use right triangles. You are going to have to do that stuff. What I'd like you to work is you're actually going to go through, the work itself is going to start on page 442. I want you to do number 4. Number 4, starting at number 4, I want you to go all the way to 12. 4 and all the way to 12. It's all just straight practice. So 442 to 444, we're doing 4 through 12. When you're done, really probably 10, maybe 15 minutes on this one. And then come back and see me and we'll go over them.